Good afternoon to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? So yeah, first of all, you tell me now here, is this audio videos clear to everybody? Check करके बोलिए. Am I audible to everybody? Is the audio videos clear to everyone? Do comment करके बोलिए. Right. चलो आज का सेशन हम शुरू करेगा. So the last class we have completed the Boolean algebra हमने discuss किया, isn't it? So now today we are going to discuss about the logic gates. आज हम discuss करने वाले logic gates के बारे में discuss करेगा. So इसके पहले सबसे पहले so I want to tell you some of the great news from Unacademy. The secret Santa is here. Yes, want to celebrate this the great Christmas, and this it will expire soon, so try to utilize this opportunity before going to expire. So within 48 hours it will expire, so try to utilize these opportunities. And the great preparation, so you can start with just 4,999 only. So the offer ends tomorrow. Try to utilize this opportunity. The flash sale which is valid up to December 24th only. And you can use a code of BVREDDY to avail this great opportunity. Done. So you can see now here there is an Unacademy scholarship test which is on 25th at 11 a.m. and 5 p.m. Two sessions are there. With this you will get to, there is a chance to get 90% of scholarship आपको मिलने का chances है. This is the one golden opportunity for the aspirants of 2027 and 2028 को. And these are the ESC 2025 rankers from Unacademy. आप देखो इधर मैकेनिकल में AIR 1 मिला. You can see now here these many ranks: civil, mechanical, all these branches. Electrical में 10th rank, right? So these many ranks are there. You can have a look at. And we planned this Unacademy test series from the December 15th onwards. Utilize this opportunity. And so we started the new batches for GATE 2028 2027 के लिए. So 27th December onwards नया batch शुरू होने वाला. That is control systems is starting. Manoj sir is starting the new subject. You can have a look at now here. The other Unacademy starters kit, which is you can able to get all the stores which is available. That is 1,099 only. 199, sorry, 199. And this is the new batch for the Asha Batch. This is for the exclusively West Bengal Electricity Department ka exams. So that is just 3,499 only. Crash Batch भी हमने launch किया. You can have a look at. Unacademy Una, I think so all of you might be using this Unacademy Una. The great features it has a voice mode, quiz mode, smart summaries. And so you can have a look at now here. So this thing, the test series which is available free of cost to all the subscribing students. And we are offering the two subscriptions. One is a plus, the other one is a iconic. प्लस में आपको क्या मिलेगा, द टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट सॉल्विंग, एवेल्यूएटेड मेन टेस्ट सीरीज, स्ट्रक्चर्ड कोर्सेस एंड पीडीएफ, लाइव टेस्ट एंड क्विज, अनलिमिटेड एक्सेस। एंड आइकॉन में क्या एक्स्ट्रा मिलेगा आपको, पर्सनल कोच मिलेगा, 1-to-1 मेंटरशिप होगा, एंड फिजिकल नोट्स भी आपको मिलेगा। So in this one you can book your time slot according to your convenience. You can start the serious preparation with the Unacademy. We are there for you to provide you the best knowledge. And these are the GATE 2025 rankers from Unacademy. So चलो आज का सेशन हम शुरू करेगा. And the today's topic we are going to discuss about the logic gates. ठीक है? All of you take your pen and paper. आपका कॉपी निकालो. So then start doing along with me. So हम शुरू करेगा. Yes, the logic gates हमने डिस्कस करने वाला basic gates and universal gates. Basic gates are what we have. Tell me now here. This NOT gate, OR gate, AND gate, and universal gates are NAND and NOR. In addition to that, we have two more extra gates are there. Those are the XOR gate and XNOR gates. ये भी हम डिस्कस करने वाला. These are the derived gates. ठीक है, चलो. Now let's talk about this thing here. So here, chalo, here symbol. Let's talk about the NOT gate. The symbol for this NOT gate is what? Tell me now here. जल्दी जल्दी हम डिस्कस करेगा. ठीक है, थोड़ा फास्ट होगा. So all of you try to cooperate with me so that we can cover the maximum topics. We'll cover it. It's the crash course, so इसीलिए थोड़ा fast भी होगा, isn't it? So this is y is equal to a bar, and the truth table is what we can see now here. If we have a is the input, y is output. अगर input 0 दिया तो output 1 आएगा, 1 दिया तो output 0 आएगा. This is the truth table. And Boolean expression is what we can say, y is equal to a bar. It has only one input. ठीक है. And switching circuit, and so here let us say this is the supply we have connected, and here we have taken a bulb. This is a bulb we have connected, and this V. Now if I call this as A, so y is equal to what? Tell me now here. Will come it as a bar. Agar if the bulb switch is on, switch is off. If the switch is off, what happens now here? So complete current will pass via in this path में जाएगा. That's why bulb is in on state पर आएगा. If the switch is in on state, there is no flow of current to the bulb, so then bulb V is in off state में आएगा. ठीक है. Next. Now if we see here, if we have the number of NOT gates we have connected in cascade, I have taken this one NOT gate we have considered, and so this output which is feedback to the input. Now here A is the input and Y is output. So now you can see, now if I try to draw this waveform, how it will come here. Initially output Y is equal to 0. अगर मैंने input A is equal to 0 दिया तो this gate will have some TPD, propagation delay. So this output Y, so कुछ time के बाद TPD के बाद it will becomes 1. So the moment this is 1, this 1 will come like this. It is feedback to here again. Now it will becomes 1. Again कुछ time के बाद again will becomes 0 ना. It will become 0. ऐसा ऐसा चलता होगा कि नहीं बोलिए. Continuously we have like this. Everybody. Like this we will get this output. Now, so how much time this is in on state? So this time, this duration is how much we can say? This is 1 TPD. And how, what about this time? This is another TPD. From here to here, this is called as time period of a signal. Na? How much is time period, you tell me? How much will be the time period T, which is equal to 2 into TPD. Okay, 2 into TPD. Here, how many gates are there inside the feedback? We have only one gate. Odd number of gates now. We have odd number of gates are there. So we have the signal. The circuit, it will behave, it will generate the signal like this. And what we'll call this signal is this type of signal, which we can call it as a clock signal now. So that's why the circuit is called as a clock generator. Clock generator. And you can see now output is continuously changing now here. So which we can call it as, what I mean of the circuit, which we can call it as so here a stable circuit. Okay, continuously the output is keep on changing, isn't it? So that's why we'll call this as a stable circuit. And this waveform, which is a square waveform now, we can also call it as a square wave generator. Okay. Now, in other manner, let us consider have taken 2 NOT gates we have taken, which are connected back to back and via feedback. यहाँ इसका PDF भी मिलेगा, हर क्लास का PDF मिलेगा, हर क्लास का PDF मिलेगा. And so if I say this is A is the input and Y is the output, yeah, you can tell me now here, agar input 0, if you are given 0, here will come it as 1, here will come it as 0. Now at the two ends of the feedback, the signal is same signal. If the signal is same, then we can call that as a bistable circuit. Then we can say the circuit, which we can call it as what I mean a bistable circuit. And this is also called as a basic memory unit. Okay. Done. Now you can observe now from this, the number of NOT gates present inside the feedback only decide the nature of the logic circuit. How many NOT gates are there inside the feedback? That is only the matter. The number of NOT gates present inside the feedback only will decide. If the number of inverters NOT gates is even, then it will behave like what you tell me? Then it will behave like a bistable circuit. then it will behave like a bistable circuit. If it is a even, it is bistable. If it is odd, then we have that is a stable circuit. A stable circuit. So the time period which is given as, what we can say here, that is 2 times of, that is number of NOT gates. Number of NOT gates inside the feedback. Inside the feedback into TPD, propagation delay. Done? Now you see in this case, the ring oscillator shown in figure, if the propagation delay of each NOT gate is 100 picoseconds, then the frequency of the generated square wave is. Yeah, you tell me now, first of all, how many NOT gates are there inside the feedback you see? Which we have 5. So that is a odd now here. That means it is a stable circuit. So this is, which we can say this as a stable circuit. Now they given propagation delay. So here propagation delay TPD given now. How much this value given? 100 pico. That means 100 into 10 power minus 12 seconds. Next, what we need a time period we can get now here. Time period of a clock signal, which is equal to 2 into 2n into TPD. So how many are there? You tell me now here. 5 are there into TPD. So that means how much will get the T clock? You tell me now here. 10 into TPD is 100 into 10 power minus 12. So how much the clock you see this thing here? That is 10 power minus 9 seconds. And now we need frequency now. So that means frequency of a clock, that is given as 1 by T clock, and which is equal to 1 by 10 power minus 9. So it will come to be a frequency of clock which is equal to 10 power 9 Hertz. So means we can say this as a 1 giga. Right? Next, the circuit shown in the figure acts as. So here you can see in this case, the circuit will behave as. What you can see now here, how many inverters are there inside the feedback? The number of inverters inside the feedback only will decide. We have 5 are there now, odd number, sorry. So total 5, but inside feedback we have only 3 only now, so odd number. So it is a stable circuit. Next, in this case, and tell me now in this case how much is n value, which is n value. So inside feedback we need to see now 3 only now, that is a stable circuit. Okay. Next, and let's talk about this AND gate. And AND gate ka symbol, and this is a symbolic representation of AND gate. This is A and this is B, and here output is Y. Output is Y. Now you can see now here AND gate, if we talk about the input combinations, we have taken this as 0 0 0 1 1 0 1 1. Now you tell me now what will come this AND gate. If any one of the input is 0, output is 0 आएगा. So here 0 is there ना, so output 0 बनेगा. In this case output 0 आएगा. Output 0, here all are ones only, output is 1. Right, so from this we can write this expression now here. So what will be the min terms you see? Min terms which we have only 3. So this is y is equal to what we have, tell me SOP form, that is AB. And y is equal to, yeah, tell me the max terms, which is equal to 0, 1, 2. So y is equal to max terms. What are the max terms? We have 0. How we can write in the POS form? A plus B. Next, A plus B bar and A bar plus B. These are the different ways we can express the AND gate. Next, and coming to the switching circuit of AND gate. This is A and this is B. Here we have connected the bulb, we have connected. This is Y. Now you can see when both are off, then bulb is also off में आ जाएगा. There is no flow of current. So if anyone is off also, bulb is off only. When both are on, then only bulb is on state में आएगा. Next, R gate. The symbol for this R gate A and B, and this is Y. So the input combinations which we have taken now 0, 0, 0, 1, 1, 0, 1, 1. Now here in case of R gate, summation. So here when any one of the input is 1, output 1 banega. So you can see now here. So this input, here there is no input is 1, so the output is 0 here. One input is 1, this is 1, this is 1. So from this we can write these expressions, you tell me now SOP form. And what will be the min terms which we have? So that is 1, 2, 3. So we can write SOP form now. That is A bar B plus A B bar plus AB. Next, and max terms are what we can say here, pi m of 0. And POS form, how we can write? That is A plus B. Right? Next, switching circuit. Yes, here we should implement what element of Y is equal to A plus B. The two switches A plus B means union means parallel में implement करना पड़ेगा. The two switches parallel to each other. Hmm. Tell me now here, when both switches are off, the current does not flow the bulb. So that's why bulb off में जाएगा. Yes, if any one is on, so bulb via that path the current will flow now. So bulb is in on state, on state, on state. Right? Next. Yeah, take this problem. Hmm. Consider the logic circuit shown in figure. The functions f1, f2 and f in canonical SOPs. Now, so tell me now what will come here. At this output. Here, can you tell me now what are the minterms will come? So AND now, AND में क्या आएगा? Common minterms will come. Common minterms are what? Tell me now. 8 is common now both में. 8 will come. Any other things will come? No, there is nothing is there other than 8. So only 8 will come here. And they given in this, what we required here, tell me now, minterms are 8, 9 we required. 8, 9 we required. So इसीलिए, so F3 में this is which gate is a R gate. That means F3 में क्या होना पड़ेगा? जरूर 9 होना पड़ेगा. It should have 9 must be there na. So that means what option? Option B. Next. NAND gate. Fine all of you. NAND gate. This NAND gate means which is a combination of AND plus NOT. AND plus NOT which will give the NAND gate. So you can see now here this is AND gate followed by NOT gate. So this AND gate and the NOT gate symbol we are using as simply a bubble, where this bubble means NOT gate. So we have A and this is B and this Y. So which will be the combination of AND gate and that is taken complement now. So I will come it as A bar. So you can tell me the input combinations. So tell me now what I will get this output. Tell me now. When both are 0, so output will come it as AND gate is 0, NAND gate is 1. 1, 1 and this is 0. Okay. And you can see the minterms. And what are the minterms here? 0, 1, 2. So we can write the SOP form. It should be given as what? A bar B bar plus A bar B plus A B bar. Next, max terms you tell me, which we have a 3. And the max terms you can see POS form, that is A bar plus B bar. Next, switching circuit. So previously switching circuit of AND gate we have seen. Now we are doing the NAND gate. We have to see it now. NAND gate is how it can be. For NAND gate, two switches we need to have. Those two switches must be in a parallel. The two switches is series and those two switches are parallel to the bulb. Okay. Now you can tell me now here in this case, the output when both are off, bulb is in on में आएगा. So anyone is off also, bulb on में आएगा. When both are on, so the current will flows in that path only, na bulb will becomes off में आएगा. Next, NOR gate. And this NOR gate is what, tell me now, which is the combination of OR gate followed by NOT gate. OR followed by NOT gate is a NOR gate. So you can see so this is a OR gate and which is followed by NOT gate. NOT gate we are indicating as simply as a bubble. So this is A and B and this Y. So the expression will come to be A plus B whole bar. So we'll come it as 0, 0, 0, 1, 1, 0, 1, 1. So tell me now the expressions. 0 plus 0. So what will come here in this case? What is the output now? NOR gate. So that is 1. So this is what will be now? 0, 0 and 0. Right? Now you can tell me the expressions here. Y. What are the minterms? You tell me now here. We have only 0 is a minterm now. And SOP form A bar into B bar. And max terms are 1, 2, 3. So POS form, this is A plus B bar into A bar plus B into A bar plus B bar. And switching circuit, so we should implement the Y is equal to A plus B whole bar. That means we have two switches, A and B are in parallel. That combination is parallel to bulb. These two switches are in parallel and this whole combination in parallel to bulb. Right, when both are off, what happen? So bulb on hoga na. If anyone on, so via that path flow of current will takes place. So then bulb is in off में जाएगा. Off में जाएगा. Next. Yeah, take this problem. The output Y is given as AB plus C bar D bar. They ask you to find what will be the gate G1 and G2s. So what I need the expression here, y is equal to AB plus C bar into D bar we required. Here what I will get now in this case, NOR gate now. So that is C plus D whole bar. That means C bar into D bar only. So this thing means if I say this should be a OR gate, and here I need to get what element of A into B I need to get. And this is A bar and this is B bar. So what should the G1 must be? What might be the G1 must be then? If the G1, if I say G1 is equal to AND gate, so will it work? So then it will come to be A bar into B bar. If it is a NOR gate, then what happens? So you tell me now, if we have this is G1 is a NOR gate, see what happens now here, this inputs are going, it is what are now A bar and B bar is going. So then it is A bar plus B bar whole bar. Then it will come to be a what tell me now here, this is A into B. Then it will be A into B will come now. Okay. So from this what we can conclude now here, G1 is which gate? NOR gate. G2 is which gate? OR gate, isn't it? So comes the option A. Next. The circuit shown in the figure realizes the function. Tell me the expressions. So we need to find this expression we need now. So here what we have, tell me now, we'll get it as A plus B bar. Next here A plus B bar plus C whole bar. So by using De Morgan's law, so it will come to be A plus B into C bar. Okay. Next here D plus E whole bar, again bar, so it is simply D plus E. So then Y. So what will get this Y value? Tell me. What will get this Y value? So this is A plus B into C bar plus D plus E whole bar. So it will come to be A plus B into C bar whole bar into D plus E whole bar. So from this what will get, you tell me. So he simplified now. So this is A plus B bar plus C into, I can write this as what I will know, D bar into E bar. Okay. So the option is D. Next. The binary operation, so they given it as slash is defined as like this, then which of the following statement is true? Okay. So if you observe carefully, what will be the this operation you see? They given x slash y, which is given as what I know x bar plus y bar. That means which I can say this as xy whole bar na. That means which is nothing but which operation you tell me now, NAND operation. That is a NAND operation. So you can see now here NAND gate. So here if you see this thing, all the logic gates will obeys the commutative property. So we have this as a OR gate, AND gate, NAND gate, NOR gate, XOR gate, and XNOR gate. XNOR gate, all these things will obeys the commutative property. Obeys commutative property. And the gates what we have, this is OR gate, AND gate. So this is this thing. So here, and this NAND gate, NOR gate does not. So this will satisfy, but NAND gate, we can say NAND gate, NOR gate, this won't satisfy the associative property, not obeys associative property. Now you tell me from this what will be the option. This does not satisfy associative property. You can see now S1 statement belongs to associative. S2 is the commutative. So that means, so this NAND gate will obeys the commutative property, but it does not obeys associative property. So then this S1 is wrong, you tell me, but S2 is correct. So this is what is the second first for S1 is a S1 is the equation, that is what, tell me now. Which one? Which one? Associative property. NAND gate, NOR gate does not satisfy associative. So that's why only, so S2 is true, S1 is wrong. Right. Now coming to this XOR gate. Exclusive OR gate. And this is why. The logic expression for this exclusive OR gate, so that is given as y is equal to, we can say this as, will denote as A XOR B. Y equal to A XOR B. Now you can see the truth tables now here. A value 0 0. So this is 0 1 1 0 1 1. In case of a, if it contains odd number of ones, output is 0. Odd number of ones, output is 1. Even number case it is 0. So you see this thing here. So odd numbers, I thought output is 1. So here in this case odd number now, so this is 1. Odd numbers 1. Remaining cases which is 0. Output is 1 for odd number of inputs. Odd number of inputs, output is 1. Otherwise, which is 0. Yeah, you can tell me now expression y. And what are the min terms you see? That is 1, 2 are the min terms. So that is y, which is equal to expression, what I can say, a bar b plus a b bar. And this y is equal to max terms are what you see, 0, 3. Then POS form is what we can say, a plus b into a bar plus b bar. Okay. Next. Now let us talk about 3 variable and 4 variable truth tables also. Fill it now here. Exam case. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Yeah, try to fill it. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, oh, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1. Okay. Now let's fill the tables now here. When the output is 1, you see, for in case of odd number of ones, output is 1. Here we have even number, so that is 0. Odd number 1, odd number 1, even number 0, odd number 1, even number 0, even number 0, odd number is 1. So in this case, odd number I thought 1, even number I thought 0. Here we have odd number, even, 0, odd number, even, odd, even, odd, even. चेक करके बोलिए. And what about the min terms, you tell me. In case of 3 variable, so what are the min terms, you tell me we have? That is 1, 2, 4, 7, 1, 2, 4, 7. And 4 वेरिएबल के लिए भी बोलिए. 4 वेरिएबल के लिए, so tell me now here y of a b c d 4 वेरिएबल के लिए. So tell me the min terms. So you will remember this as 1 2 4 7. तो आपको स्मरण होगा ना. We remember this 1 2 4 7 easily. बाकी को क्या करेगा? So this last one is how much, you tell me now? 15 na? Yes, so that means what I can say, 15. 15 minus 7. If I do it now, 15 minus 7, what will come? It will be 8 will come now. Next, 15 minus 4. 15 minus 4 will come it as 11 will come. 15 minus 2 will come it as 13. 15 minus 1, so will come it as 14. All of you tell me. Yes, now will you remember this thing directly? Tell me. Like this we easily remember, now tell me. So the minterms. Like this we got the minterms of all. So fourth variable also minterms we have got it. La 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 la. Next. Now let's talk about a switching circuit also. Switching circuit of XOR gate, you tell me now. Y is equal to what we have, tell me now. A bar B plus A B bar now. And we can fill it A bar B. So that means A bar B. So this is A bar and B. These are in cascade, means series connection. So this is A bar and this is B. And next we have A and this is A B bar. And this is A B bar. This is series. Now this whole combinations we have connected and we are connecting to a battery. Okay, and you can verify now here. When A off, both are off, then what happens now here? Bulb is in off में जाएगा, check करके बोलिए. Next, A off, B on. So then bulb is in on, so the bulb is on, here it is off में जाएगा. Okay. Next, let's see here how when the XOR gate will behave like a buffer and when it will behave like an inverter. Now, so I have taken XOR gate. A, I have given, let us say this input I given as 0. Tell me what happens. So tell me now A XOR with 0. What will come? What will come? This is will come it as A only na. A only na. If one of the input for XOR gate is 0, then it will behave like a buffer. Okay. Now and this input, now this is A, and if I given one input as 1, so what will come this output? You see A XOR with 1, so will come it as what? Tell me now here, inverter. A bar will come, check it. So that means we can conclude this as what? Tell me now, if अगर एक one input which is equal to 0 आई तो it will behave like a buffer जैसा काम करेगा. If one of the input is a inverter, so then it will behave like is a 1, it will behave like inverter ना. Next, now let's talk about the properties of XOR gate. Tell me now, what is A XOR 0? अभी ने देखा, if the one of the input is 0, it will behave like a buffer na, so that is A. A XOR 1, so it will commit as what else now, A bar. So if the both inputs are same inputs, the output of XOR gate is why we are using buffer as output same as input. Yeah, buffer means, yeah, exactly, buffer का मतलब is what, output is same as input na. So jo output is same as input, then we can say buffer we should call the same language I'm using in the analog circuits EMT. You might be heard now these things. Buffer का मतलब is what, tell me now, जो input में दिया वो output पर आएगा, that is a buffer. That's why we are using this words. Okay, buffer का मतलब, so here जो input दिया वो ही output पर आएगा, right? Yeah, so this time, so here this Sunday तक चलेगा यार, this Sunday तक same timing चलेगा. This Sunday तक I will try to complete the maximum topics I'm planning to complete. This Sunday तक होगा daily class, same timing 2 to 5 o'clock. AXR with A, so will be 0 na. So XOR gate, if the two inputs are same inputs are given, output is 0 बनेगा. If the different input case, output is 1. Is this thing is clear? Next. And you can see now A like this we have n times are there. If n is odd क्या होगा, n is even क्या होगा? EMT will plan after this. If n is odd will come, A only will come. If n is even will come it as 0. Check करके बोलिए. So एक एग्जाम्पल ले लो, n वैल्यू 2 ले लो, 2 चेक करके n वैल्यू 3 ले लो, वेरीफाई करो. अगर n वैल्यू 3 ले लिया तो, so that means what happens now here, then A XOR A na. So this is A XOR A which is equal to 0. So this will come to be A only na. Now if n is equal to 2 we have taken, okay, 2 we have taken, then what happens now here, A XOR with A, it will come to be a what, tell me now, 0 will come. Signals, those things we'll do in the special classes will do. I am planning to in the special classes signals is running. Next. Tell me what I'll get. A XOR with A bar plus B. Try करके बोलिए ना, what will come? This is how the form you can see now here. P XOR with Q may. That is what we'll get now here. P, so here P bar. P bar means P place we have A na. So this is A bar into Q. That is A bar B plus, okay, so there is no bar here. Next, this is A bar into A bar B. So what will come then? So which will come it as A into A plus B bar plus A bar B. So this is A plus A B bar A bar B. Then it is A common. This is 1 plus B bar plus A bar B. So this is equal to A plus A bar B. Okay. So you observe here. So if you observe carefully what I got, A XOR with A bar B, which will come it as what, tell me now here, A plus A bar B. So this property you try to understand here. So what is this? Actually we have, this is the XOR. In this case XOR behaving like a R only. You need to understand. XOR behaving like what, tell me now, R गेट जैसा काम करने वाला इधर. Okay. So thereafter what I can do, we can simplify it now. A plus A bar B, we can apply mingle property, then will come it as A plus B. Okay. Next, yeah, you tell me now what will come. AB XOR with BC. So here also, so we can say this is P XOR with Q consider करके will simplify it. Tell me now what we'll get now here. AB bar into BC. A bar B plus AB bar. A BC whole bar. So you can tell me what will come. A bar plus B bar into BC plus AB into B bar plus C bar. So it will come to be A bar BC plus 0 plus 0 plus ABC bar. Finally, either if we have taken this as a B common, so then what we have, tell me now here, A bar C plus AC bar, which is equal to B into what I can say now, A XOR C. So finally what we can say, tell me now, AB XOR with BC. So that means what I did now, we have simply taken a B common we have taken. You see, here we have taken the B common, isn't it? So that's why whenever we have like this in XOR, we can take the terms, we can take common also. I just want to show this thing from this example. Next, yeah, try this problem. f is equal to x XOR, if we are taking the y common here, that is 1 XOR with x na, then it will come to be x XOR with y into x bar, that is given as x XOR with x bar into y. So in this case, what we can do, I can, XOR gate will behave like a OR gate. So we have seen previously. So this is nothing but x plus x bar into y. So this will be given as, what tell me now here, x plus y. Next. Yeah, this we can treat as P XOR with Q. Now simplify it now here. A bar B whole bar into A B bar plus A bar B into A B bar whole bar. Tell me what will come. This is A plus B bar into A B bar plus A bar B into A bar plus B. Then it will come to be a B bar. Okay, A B bar plus A bar B plus A bar B. So then it is nothing but A B bar, I can say, and A bar B. So this is nothing but what, tell me now, A XOR B itself. Okay. Next. Chalo. Now we'll move to the next one, XNOR. Ha 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 ha. That is, we can say XOR plus NOT is called as XNOR gate. And the symbol is XOR gate followed by NOT gate. And this is XOR gate. NOT gate we can indicate as a bubble like this. And the symbolic representation is what I will now A XNOR B. You can see now here when both inputs are 0 0, 0 1, 1 0, 1 1. Now you can tell me now what will come these outputs now. So here in case of even number of ones, output is 1. Here 0 is an even number only now, so that's why output is 1 here. Here different, so output is 0 0, this is 1. Okay. Now you can tell me the min terms here. We have 0, 3 is a min term. And the expression what we can say here, A bar B bar plus AB. And this is given as max terms, which is equal to 1, 2. So POS form, that is, will come it as A bar plus B into A plus B bar. and the switching circuit, that is y is equal to what? Tell me now. A bar, B bar, A bar, B bar plus AB. A bar and B bar. A bar and B bar. And we have two switches. A and B are connected in series like this. Here is a bulb. Okay. Then now, so let's fill this table here. Take this one. So XNOR. XNOR is what? Tell me now. Even number of ones. So even number, so this is 1. Even number, so odd number 0. Even number, so even number, no, odd number, na? So 0. Even number 1. Odd number 0. Even number 1. Even number 1. Odd number 0. Okay. Now in this case, XOR gate. And this is XOR gate is what will be now odd numbers. So this value 0, odd number of ones, even number 0, odd number is 1, even number 0, odd number is 1. Got it? Now you tell me now here, first this is A and B only. So this means we need to see A and B XNOR gate. Yeah, tell me now here 0, 0. So here 1, 0, 0. It is 1, 0, 1, 0. 0, 1, 0, 1, 0, 0, 1, 0 also 0, 1, 1 is 1, 1, 1 is 1. Now with this, what I should do now here? So now this is this one and this we need to see now. 0, 1 will come it as what you see? 0 and 1. So it is 0. 1, 1, 1. 0, 0 will come it as what element of 1. 1, 0 will come 0. 0, 0, 1. 1, 0. This is 0. 0, 1, 0. 1, 1 is 1. Check it all of you. Next, A and C tell me now here. We should do A and C now. So this and this we need to see. Tell me now what will come here. 0, 0 will come it as 1. 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. So this is 0, 1, 1 is 1. Now we should do what? Tell me now here. This is B with AC. We should do it here. Now tell me now here. 0, 1, 0, 0, 0, 1, 1, 1 will come it as 1, 1, 0, 0, 0, 0, 1, 0, 1 is 0, 1, 0, 0, 1, 1, 1. Okay, now you see the beauty here. अगर आपने ध्यान से देखा तो here you see this thing here. First of all, these two are complement to each other. First thing, XR and XNOR are complement to each other. And another beauty you need to observe, these are equal. See the beauty. Okay, these things are equal. अरे वाह, ये तो कमाल की बात है. So you need to observe here. When you are writing this, let us say y1, if I call y1 of A, B, C, and which is equal to, if I say A XR, B XR, C. So tell me the min terms are. What are the min terms you can see now? XR here 1, 2, 4, 7. Okay, next if I call this y2 as A, B, C of this is A XNOR, B XNOR, C. Tell me now what are the min terms you see? 0, 3, 5, 6. So from this clearly we can say that XNOR and XR and XNOR are complement to each other. Okay, यहाँ तक there is no problem at all. But here you need to ध्यान देना पड़ेगा. Oh, what important observation. What is that here? We have taken this as y3. If I have taken A, B, C, that is, you tell me now A XNOR B, XNOR C. What will come, you tell me now. So iska min terms, what tell me now? Surprisingly, we got this as 1, 2, 4, 7. Check करके बोलिए इधर. Huh? Surprisingly, it will come like this. A XNOR B XNOR C. And tell me now इसका min terms क्या है? 1, 2, 4, 7. देख के बोल. बढ़िया से बढ़िया लॉजिक है. कमाल की बात है इधर. This thing. This is one important observation you need to make. ठीक है, चलो. Now let's talk about when this XNOR gate will act like a buffer. So that is here 1 XNOR with A. What will come here? A will come. From this we can say buffer. Yes, 0 0 XNOR with A. So what will come here? This is A bar. This is A bar. So we can say inverter. That means if the one of the input is, one second, ulta हमने लिखा. This is 0 XNOR with A. Then it will come to be a what? Tell me. Then it will come to be a bar. This is 1 XNOR with this thing. So then it will come to be a. Okay. This is opposite to XOR gate. XOR gate, one of the input is 0. It will behave like a buffer. But here XNOR, it will behave like an inverter. This point you need to observe. And you see the properties now here. XNOR gate. Tell me now, if one of the input is 0, how it will behave? You tell me now. Buffer inverter, XNOR gate. Buffer inverter, so it will behave like inverter. If the input is 1, so it will behave like a buffer. A XNOR A, both inputs are same, output is 1. Alag inputs, output is 0. Different inputs, output is 0. So this is whole complement. So it will come it as obviously what? Tell me now. XOR gate will come. If only one bar is there, so then operator will change. It will becomes XOR na. So that means it will becomes XNOR banega. Okay. So one bar is there, so XR will becomes XNOR banega. If the two bars are there, so operator remains same. It does not disturb. देखो either we have only one element is complemented, so XR will becomes XNOR. If A and B both are complemented, XR is XR only. Next, A bar XNOR B bar. So now A and B both are complemented. So what happens now? Will the operator change or retain? Will remain same? Operator remains same only. So this is XNOR only. Okay. So this is the broad. So the things what we have seen. When the output of XOR gate is 1, you tell me. Output is 1 and XNOR gate. When the output is 1, you need to see. So output is 1 for whatever odd number of ones. Here the output is 1 for even number of ones. That's the reason XR will call it as an odd number of ones detector. Odd number of ones detector. And this XNOR is called as even number of ones detector. Okay. And this is the inequality detector, which is also called as inequality detector, XR. If the different inputs are there, output is 1. Same inputs are there, output is 0 in case of XR. And XNOR is called as equality detector. Equality detector. And this we can also call it as what? Tell me now here, anti-coincident logic. This is an anti-coincident logic, and this XNOR is called as a coincident logic. Coincident, same. If the both inputs are same, then output is 1. Different inputs, output is 0. Okay. Oh. Done. Now let's see some problems. Simplify the following. Tell me now what we can do. F is equal to A XOR. So what we have, tell me now here, A B bar XOR with A bar. Since XOR gate will satisfy associative, we can jumble them. So इसीलिए हमने, what I am doing is I am jumbling here. So or we can apply directly for these two. Can you apply the relation where this XOR gate behaving like a OR gate? ना हमने देखा ये property. So we can say A plus A B bar and so here we can directly take A common now here directly, no need to do this much here. A common, this is 1 XOR with B bar and XOR with A. So that is F is equal to A into 1 XOR with B bar, which is equal to what will come here, B. B XOR with A bar. Then F is equal to, this is A bar XOR with AB. That will come it as what element now, A bar plus AB now. XOR gate will behave like a OR gate only. Then which will be equal to what I will get now here, this is A bar plus B. Okay. Done. Next. Yeah, you can tell me this one. F is equal to A XOR B XOR with A XOR B bar. Now, so it will come to be a, so this is A XOR B XOR with, this is what element now, A XOR B bar, so it will come to be a XNOR na. So this is what we can see, A XOR B, this is XOR with A XOR B ka whole bar. Then it will come to be a, what we can say, tell me now, 1. डिफरेंट इनपुट्स ना आउटपुट 1 बनेगा. नेक्स्ट, so which is equal to A XOR B plus what? Tell me now here. So A XOR B whole bar. What will come? You tell me. This is A XOR B plus what? Tell me now. This is A XOR B banega na? Tell me. So this is A XOR B plus XOR, we can say it as XOR whole bar. So this could be given as in the form of, you have taken P is equal to A XOR B. Then it will be of the form P plus P bar form na. P plus P bar, which is equal to what? Tell me now. 1. Next, try this one. If we have like this. Now first of all, you see this thing here, 1 XOR with P, so which is equal to P bar. XOR with P, XOR with Q, and this XOR with P, XOR with Q, and this is XOR with what? Tell me now. Q na buffer. Now P XOR with P bar, which is equal to 1 na. 1 XOR with Q, XOR with P, and this is what will get you? Tell me now here, which is equal to 0. Same inputs, output is 0. Now 1 XOR with Q, so that is nothing but Q bar, and this is what? Tell me now. P, so that is P XOR with Q bar. Yeah, that is nothing but P XOR Q na. Yes, that's it. La 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 la. Got it? Hmm? Next one. The output of the circuit is now, so it will come to be A XOR B bar. So which is equal to A XOR B na. And this is A XOR B bar. This is A XOR B. Now you see this thing, this gate is a XNOR gate. XNOR gate, we have given same inputs are given or different inputs are given. So same inputs we have given, so then what will be the output? You tell me now. 1. So same inputs are given, output is 1. XNOR is called as a equality detector, coincident logic. XNOR is a equality detector. Next one. The output of the combination circuit is. Tell me the output in this case. So here will come to be a AB. Here will come to be a BC. Next here C will go here. Next it will come it as what? Tell me now here ABC. Here. So this is AB XOR with BC. Now what is this Y value? Tell me. So that is ABC XOR with AB XOR with BC. So this Y value come to be a, if we have taken it as AB have taken common, then it is C XOR with 1 XOR with BC. So that is Y will come to be a AB C XOR with 1. So this will come to be a what terminal? C bar XOR with what element of BC. Then from this will come it as what element of B common. Then it is C XOR with AC bar. Okay. So tell me now what will come from this. Then which is equal to B into C. So this is C XOR with AC bar. What will come here? This is will behave like a C plus A na. So finally which will come to be a B into, yeah, that is A plus C. So kaun sa option you see? Option C is there. La 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 la. Oh. Next, for the logic circuit shown in the given figure, the required input combination to make the output is 1. So I need this output must be a 1, and this gate is an AND gate. AND gate output is 1. When can happens now? All the inputs are 1. All the inputs are 1, then only output is 1. So that's why, so this input must be a 1. So this is which gate? You see this thing here, this is XNOR gate na. When the XNOR gate output is 1, both inputs are same. So this must be also 1. That means B must be a 1 na. And this given as what element of XOR gate. When the output of XOR gate is 1, so so both inputs are different inputs we need to have. So from this we can conclude this thing now here. Finally, how much is A value? Tell me now 0. B value how much? You tell me now 1. C value how much now? You tell me now 1. Okay. Next. If the input to the logic circuit consisting of a cascade of 20 XOR gates is X, then the output Y equal to 20 XOR gates are there. So here we'll consider some even number, will verify it. So here up to here 2 we have taken. So here we have 1 XOR with X now. Will commit as X bar. Now this is X bar XOR with X. So it will come to be a 1. So what will be the answer? You tell me now. Y equal to 1. Next, the output of the digital logic circuit shown in the figure is. Tell me now this output. X XOR with Y. Next, here we have this is input is this only now. Now here will come it as X XOR with Y XOR with Z. So then F, which is given as, so that is X XOR with Y into X XOR with Y XOR with Z, then which is equal to X XOR with Y. If we apply this thing here, so I can write it as X XOR with Y bar into Z bar plus X XOR with Y into Z. Now when you multiply this thing, what will come here? Will come it as 0 this term, first term 0. Second term is X XOR Y into Z. So from this we can write it as, what? Tell me now here. X bar Y plus X Y bar into Z. Next. Right. Now let's talk about this alternative logic. Alternative logic means how we can represent this one some other way. Buffer. Two times we have taken complement, so obviously will come it as buffer only will come now. A bar is passed to a NOT gate. Okay, NOT. Yes, able to follow now all of you. Am I going speed? Able to follow everybody? Right. Next, AND gate. I have taken a bubble to NOR gate. I am taking. A and B, and this Y, which will come to be a what element now? A bar plus B bar whole bar. So that is nothing but what element now? AB only now. Next, OR gate. Bubble to NAND gate. that is what will be now A bar into B bar whole bar, and which is equal to what will be now here A plus B. NAND gate, bubbled AND gate, bubbled OR gate. So this is which is equal to A bar plus B bar. That is nothing but what will be now AB whole bar only. NOR gate, bubbled AND gate. This is A bar into B bar, which is nothing but A plus B whole bar. Right? Next, XOR gate. I have taken XNOR gate. One input is complemented. So this is A and this is B. Tell me what will come here. A bar XNOR B na. So that is what will be now A XOR B. Or we have taken B is complemented. Now B is complemented. So this is A B. So this is what we'll get now here A XNOR B bar. So then it will come to be A XOR B. Right? Next, XNOR. Same analysis. I have taken as XOR gate. One input is complemented. So that is A bar XOR B. That is nothing but what element of here? A XOR B. Now RB is complemented. Right? Yes. Now let's talk about how we can implement the logic gates. So the NAND. So we have to implement a given expression by using NAND gates से implement करना पड़ेगा. So we'll do the one by one procedure. First we'll do the basic method. Basic method. First of all, the given expression is SOP form. If it is SOP form, for if I want to implement by using NAND gates, keep in mind the expression must be in SOP form. The expression must be in SOP form. Now here, so we can implement it now here. So first AC basic, this is already SOP form and directly no need to simplify further. So this is AC. Next we have BC. Next this is B and this is C. Next we have AB. And these all we have connected to a OR gate. Assume that 3 input OR gate we have taken. So this is Y. This is the way we'll implement. So first we implemented all this thing by using what, tell me now? So here AND gate, OR gate we have taken. Now I want to convert them into NAND gates. So NAND gate ke liye, so here we should have bubble required now, so we'll place a bubble here. If I place one bubble, so bubble means not. So I need to compensate that bubble. So to compensate this thing here, we added one more bubble we added. Here we placed one bubble and we added one more bubble here. So this is bubble and this bubble. Okay. Now this will become NAND gate. This also NAND. So this is the bubbled OR gate. As we know, bubbled OR gate is nothing but what, tell me, NAND gate only. Isn't it? So that's why we can finally replace them as what we can say now here. So this is a NAND gate. This is another NAND gate. And this is another NAND gate. And here we have taken a 3 input NAND gate. Now this is AC, this is BC, this is AB. Okay. Now how many NAND gates required now? This is 1, this is 2, 3 and this is 4. This is Y. Y is equal to what? Tell me now. AC plus BC plus AB. Okay. This is the way we have implemented. अगर आपने ध्यान से देखा तो here this is a level 1 and this is a level 2. Previously what we have, tell me now, level 1 we have a AND gates are there na. Level 2 what we have, OR gates are there. So here if you see carefully, all these AND gates and OR gates we replace with a NAND gates we have replaced now. This is how many levels? 2 level. 2 level NAND logic. 2 level NAND logic, which is exactly equal to the 2 level AND OR logic, I can say. Isn't it? Right. Next. Now let's see the next one here. Implement by using NOR gates. Here they ask us to find two implementation of what, tell me now, by using NOR gates. Whenever you want to implement by using NOR gates, means the expression must be in POS form. If it is not, we should convert into POS form. Then only we have to proceed it. So the given expression which is already in the POS form only, so no need to do here. We can directly will proceed it. So first we have taken one OR gate. I have taken. and this is A and this is B. Next we have taken one more OR gate, we have taken and this is C and this is D. Now these two are connected with a one AND gate. Now this is the expression. Okay. Now we need to convert this into a what terminal NOR gate. So for this we are placing a bubbles here. If I place one bubble here to compensate, we have one more bubble here. I am placing one bubble and to compensate one more bubble here. Now you tell me now here, this circuit will becomes as what you see. And this is a one NOR gate बन गया. Now this is bubbled AND gate is nothing but NOR gate only na. This is also one NOR gate. This is Y. Okay. Got it. This is the way we'll implement the. So here and here also we can see this is what I mean level 1, this is the level 2. Level 1 which we have this as a OR gate. Level 2 what we have tell me now AND gate. These are two level OR and logic, which is nothing but what I can say NOR logic. NOR logic. Okay. So you can see now that what we have to conclude now here. So here you see this thing, a two level AND logic which is equal to two level NAND logic, and two level OR and logic equal to two level NOR logic. ये बात समझ में आया? बोलिए सभी को. This is a very important point you need to focus. Done? Next. Enter the next problem. Y is equal to A plus BC implement using NAND gates. They are asking to implement the NAND gate. NAND gate के लिए the expression must be कौन सा form में होना पड़ेगा? So it must be in SOP form, which is already in SOP form only now. So no need to disturb. We can proceed. So but here we are making it as what element of Y is equal to, I am writing it as A into A plus BC I am calling. Okay. Only one input now, so two inputs I made. So then which we can write as what tell me now here in this case. So this is a basic method. So which we can say this is what tell me now level 1, this is one AND gate, and this is another AND gate we have to use now, and then together all together we should go for OR gate. This is a two-level AND logic, which is nothing but NAND logic only na. So that's why which we can implement it as, that is directly NAND gate se implement karega. This is A level 1 and this is BC, and we have taken this is Y. Y is equal to what? Tell me now. A plus BC. Got it? This is one way. The other way we are going to do it as what? Tell me now. By using the concept of double complement method. Let's see what is the double complement method also. Here Y, which is equal to A plus BC given a. I am taking 2 times complement I have taken. If you have taken 2 times complement, we'll get back the original form only. So then Y, which will come to be A. So this is A bar into BC whole bar, again whole bar, upar. A bar. Y. Yes, it will come exactly same thing. Check karo. This is the way. Now you can see now here. Implement using NOR gates. NOR gate के लिए the expression कौन सा फॉर्म में होना पड़ेगा? Tell me now. NOR के लिए the expression must be POS form. But here this is not a POS form now. So we should convert into POS form here first. So for this we are applying a mingle property, that is A plus B into A plus C. Okay, now you can see now here we required one OR gate. This is one OR gate. Thereafter whole thing we use one AND gate. This is the procedure now. And so here and this is A, B. And this is AC. Now, and I have taken this as one AND gate. So we'll get like this. Now, so after that, all the AND gates we can replace it as a NOR gates we should replace. Now this is a NOR, this is NOR, and this is also we replace a NOR gate. Okay. Now you can implement it. So tell me now what we can do here. We use a double complement method. That is Y is equal to A plus B into what? Tell me now here, A plus C ka whole bar, again whole bar. So this is A plus B bar plus A plus C bar whole bar. AB. And this is AC. Okay. Next. Take this problem. Now look at now here. So let us call this is F. So that is F is given as what? Tell me now here. W bar plus X bar into Y plus Z. This we are writing it as what? Tell me now here. WX whole bar into Y plus Z. If we multiply this thing, WX whole bar into Y and WX whole bar into Z. Now you can tell me now here. So how to implement this thing here? Double complement method. This is WX bar into Y plus WX bar into Z whole bar again whole bar, which is equal to WX bar into Y whole bar into WX bar into Z whole bar again whole bar. Now first I am implementing with WX. So WX required. Now first I am implementing WX. So this is WX. Here will come it as WX bar. Next here I have taken one more NAND gate. I am taken. Here I am taking the another NAND gate. And this is given. Both the NAND gates. And for this one we required what? Tell me now here. Y required now. And for this one we require the Z we require. Z is connected. Now another NAND gate I have taken. This given the inputs as like this. The finally we'll get this output is this much. Yes, check karo. Here will come it as what? Tell me now. WX bar into Y ka whole bar. This is WX bar into Z whole bar. So what will come here? WX bar into Y bar into WX bar into Z bar whole bar. Okay. Got it? What is the NAND gate? Universal gates means what? NAND gate and NOR gate are called as universal gates now. NAND and NOR gates are called as universal gates. Next. Now you can try to answer this thing here. How many NAND gates required for implementation of buffer? How many? 2 required. NOR gates also 2 required. How many NOT gates are? Only 1 is sufficient. AND gate, NAND gate, AND gate comes under same family. Same family though, so that is 2 only. But the different family is 3. R gates are not belongs to AND family, so that's why here 3, here 2. XOR gates, how many? 4. XNOR gates, NOR gates are 5. XNOR gates are 5. Here this is 4. NAND to NAND 1. NAND to OR gates. So how many? 4. NOR gates. How many? OR के लिए how many requires? OR के लिए how many? 3 required. 3 plus 1, 4. This is 1. Yeah, try to remember, sometimes 1 mark questions may come. How many gates are required? How many NAND gates required for the implementation of XOR gate, XNOR gates? Okay. Yeah, Venn diagrams. Yeah, tell me the Venn diagrams के लिए. Buffer. Buffer means what? Tell me now basically. So we should implement y is equal to a. So we need to shade the region. Which region I need to shade now? Complete. पूरा अंदर शेड करना. Complete this region, we have to shade it. This is a y equal to a. Right. Complement. So that means y is equal to a bar now. So what I need, where I need to shade now here? Sample space we have to shade. Sample space we have to shade. Except a, we have to shade. Okay, except a we have to shade it now. Outside the circle. Next, AND gate. AND gate means y is equal to ab. Where I need to shade, you tell me now. Where I need to shade. Only common part we need to shade now here. So this part we need to shade. This is the common part we shaded. A into B. Now OR gate. Tell me the OR gate is A plus B. So where I need to shade, you tell me. Outside part we need to shade it now. Sorry, A, complete B, we have to shade it now. All A, all B, including common part also. Yes, this is A and B, both A and B we have to shade it. Next, yeah, NAND के वो बोलिए ना भैया. Y is equal to AB whole bar. Means where I need to shade now here, NAND case. If it is a AND, so whenever we have complement is there, first we say AND, thereafter NAND you see. If it is a AND, we should share the common part. But because of the NOT, except that we have to shade completely. That means where we have to shade now here, except the common part. Except the common part, we have to shade the whole part, we need to shade it. Except the common part. Okay. Common part we have to remove. Except common part. Yeah, tell me now here, y is equal to NOR gate. A plus B whole bar. In this case, where I need to shade? If it is R gate, A and B both we need to shade. But except A and B. So means here outside the circles only we need to shade it now. No A, no B. This part. Next, XOR gate. Tell me now XOR gate. First understand the equation. XOR gate के लिए what should do here? A bar B plus A B bar means where I need to shade A bar B. So केवल A, केवल B. Only A. Only A means what? Tell me now. This is only A na. This is only A. Common part we should not shade it now. And this is only B. All of you tell me. Only A, only B, we have to shade it. Now you tell me now XNOR के लिए. A bar, B bar plus AB. Where we need to shade, you tell me. AB means what? Tell me now. Common part na. This part. And A bar, B bar means where, you tell me now here. A bar, B bar. So here outside part na. No A, no B. Okay, understood? No. Yeah, let's see some problems now. Yeah. Yes, diagram is visible now to you, all of you. This is R gate. And these are F1, F2 are passed through this R gate. And they are asking to find what will be the F will come, output will come. This is F1, F2 are passed. What is the min terms of F they are asking? Tell me. Min terms of F, what will come? So this is F is what? Tell me now here. F1 plus F2 na. F1 plus F2 means union. Union na. So what are the min terms will come? All the min terms will come na union. 0, 1, 2, 4, 5, 8, 10, 14, 15. Next. Now tell me for this is an AND gate. Now F1 and F2. F. AND gate is what? Tell me output is F1 into F2 na. Tell me now what will come. Common minterms only will come na. So what are the common minterms you see here? Yes, 2 is there, here also 2 is there. Okay, next what else is there? Next we have 8. Next 8. Any other? No. That's it. Only 2, 8 will come now. Next. Yeah, tell me if it is a NAND gate, what will come? Here they given this is a NAND gate now. For NAND gate, what will come, you tell me? So here we have this is F1, this is F2 and this is F. Before this, what we'll do here, first of all, if it is a AND gate, what will come, you tell me? Just before bubble. Before bubble, if it is AND gate, what will come? Will come it as 2, 8 will come na, common? Yes or no? 2, 8 will come. So that means after bubble, what will come here? Except 2, 8 remaining will come. Understood what I am saying? Except 2, 8 remaining will come. So that means what are the minterms you come, you tell me now? So that is 0, 1, 2, 9, 3, 4, 5, 6, 7, no 8, 9, 10, 11, 12, 13, 14, 15. समझ में आया all of you? Okay. Whenever the bubbles are there, first you do analyze before bubble and after bubble. Otherwise, there's chance to commit a mistake. Okay. Next. Tell me in case of NOR gate. What will come? Here also same procedure. First you see the before bubble. Tell me. Before bubble, what will come? Union na? So what will come here? 0, 1, 2, 4, 5, 8, 10, 14, 15 will come before bubble. Then what will come after bubble, you tell me now? Except this thing remaining will come now. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's it. So समझ में आया all of you? बढ़िया. Yes, अगर आपको समझ में आए तो दिल बना लो सभी ने. दिल Next. Now you tell me now, बढ़िया, either you will get it as XOR gate and XNOR gate. इधर भी बहुत बढ़िया आएगा. Tell me now here, XOR gate, XNOR gate, what will come? You have to be very careful for this XOR gate. XOR gate में क्या आएगा? Tell me. So this is F1 and this is F2 and this is F. XOR gate, first of all, what is the equation of XOR? You understood first of all A XOR B, which is equal to what? Tell me now. A bar B plus A B bar. Okay, that means what is the meaning of A bar B? Means only A, only B, only A, only B. So if we see the Venn diagram also, recollect the Venn diagram of XOR gate also. Now tell me now, XOR gate Venn diagram. So this is A and B. What will come? Only A will come, only B will come. That means what happened? Only this A, only A, and only B will come. Common terms won't come, outside terms also won't come. Yes or no? Tell me. Common terms won't come, outside terms also won't come. So you tell me now, what are the common min terms here? You see, common min terms. 2 is common, 2 won't come. 8 is common, 8 won't come. Except that remaining will come. So those are what we can say. Tell me. So 0, 1, 4, 5, 10, 14, 15. समझ में आया? Tell me. Common things won't come, and outside terms also won't come. Right? Next, XNOR gate. Tell me here. He also first what will do here? First, before bubble you see, thereafter you see the bubble. Okay. Tell me now, before bubble what will come? That means before bubble means XOR gate. XOR gate common terms won't come. Outside terms also won't come. So tell me now what will come here. Common terms won't come. So the common terms we remove. 2, 8, 2, 8. So this is 0, 1, 4, 5. That is 10, 14, 15. And what is this one? Because of the bubble, what will come here? Except this thing remaining will come. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Got it? Got it? Got it? Got it? Done. Now take this next problem. All of you do like the session, share to all your friends. And for you only we are doing this session. So everybody do participate. So so that with a lot of enthusiasm and with a more motivation we do this regularly session, we can plan it. So you can see now here, which is this is P bar. Here will come it as Q bar. This is R bar and this is S bar. So what will come here? This is P bar into Q bar whole bar. This is R bar into S bar whole bar. So that it is P bar into Q bar whole bar whole bar. So it will come to be a P bar into Q bar only. And here also it will come to be a R bar into S bar. Finally, Y will becomes as what? P bar into Q bar into R bar into S bar whole bar will come to be a P plus Q plus R plus S. Okay. Done. Next. A digital circuit is given. Oh, here these options are missing. Options are missing. Yeah, I will write these options. You take these options. Options are 1 0 1 0 1 0 1 0. So second option 0 1 0 1 comma 0 1 0 1. Option C 0 0 1 0 0 0 1 0. Option D 0 0 1 0 1 0 1 1. One zero one one. Tell me this thing. Which case the output is 0. This value, y value we need to get 0 we should get. this XOR gate now. In this case, which case will happens now? You check this option D. So here we have taken 0 and 1. 1 0 0 0 1 1 1 1 0 1 0 1 will come to be a 1. So this is 0 0. This is 1. This is which gate is a NOR gate now? Will come 0. Only in this case is 0. Check it, all of you. Only in this case only 0. Fine. Okay, fine. So that's it for today's session, and we'll meet in the next class. Okay, next class we'll discuss the number system will start. What we'll do here, directly we'll do the K-maps. Sorry, combination will do. Next class what we'll do, we directly will start the combination. हम शुरू करेगा क्या? If we are comfortable with the K-maps, then we can directly do the combination part will do. What you'll say? Next class we'll do combination part. Control systems. Yeah, so we'll get to know the information. All of you do like the session, share to all your friends. Ask them to join. Okay, share this session to all your friends. Okay then, see you. Bye-bye.